Welcome to Logan, Casey's, and Kyle's Wedges project. This is our plan for reducing carbon emissions over the next 35 years, one wedge at a time.
8 billion tons of CO2 are released into the atmosphere yearly, but only 4 billion tons are removed naturally. Carbon dioxide in the air causes the greenhouse effect, which is when gases in the atmosphere retain heat that, in turn, heat up the Earth. Although this effect is necessary for life, too much gases can cause acidification of the sea and rain, global warming, and many other complications. To reduce emissions, stabilization wedges are used to show ways to make energy while producing little or no carbon emissions. Each wedge represents a way in which 1 billion tons of carbon can be prevented from being released into the atmosphere. Throughout this lesson, we will discuss 8 different ways, or wedges.
Here we have nuclear energy. Nuclear energy is part of the electric sector, and we would displace enough coal-burning electric plants to triple the current capacity of nuclear energy. This would account for one wedge's worth of CO2 reductions, and despite its upfront cost and the stigma it carries, nuclear energy is a safe, efficient, and long-term cost-effective energy source.
Switching from fuel to electricity resides in the electricity sector. Our plan is to reduce about 1,400 large coal-burning electric plants with natural gas plants. They only release about half the CO2 emissions as coal burning and are just as energy efficient.
This wedge falls into the transportation and heating and direct fuel use sectors. Sooner than one might think, a significant portion of fuels will be synthesized from coal, and this process is extremely heavy in CO2 production. We would use carbon capture storage to remove the emissions of 180 synthesizing plants from the atmosphere, accounting for one wedge.
Wind energy resides in the electricity sector. Despite it providing a measly 1% of the world's current energy, it needs only to be scaled up by a factor of 10 to provide one wedge in CO2 reductions. This would require about 1 million new wind turbines to be built, along with 3% of all American land, but the land they are built on can be used for other purposes as well.
This wedge obviously deals with the electricity sector and is one of the more simple solutions to the carbon problem. Today's coal-burning power plants produce about 1/4 of the world's total release of CO2. Producing the world's current coal-based electricity with doubled efficiency would save a wedge worth of carbon emissions. Through the use of better turbines, high-temperature fuel cells, and from combining the two, the efficiency of power plants can easily be doubled.
This wedge falls into heating, direct fuel use, and transportation sectors. Commercial and recreational account for a large portion of carbon emissions, and heating, space and cooling, water heating, lighting, and electric appliances are the main sources for this energy consumption. If emission were cut by 25% in all new and existing residential buildings, we would cut down carbon emissions by one wedge.
Forest storage is our only wedge to pertain to the biostorage sector. Land plants and soil remove significant amounts of carbon from the atmosphere, but due to deforestation, about 1.5 billion tons of CO2 are added to the atmosphere. Our goal here is to simply end deforestation. If we can, the reduced emissions will total out to one wedge. Along with ending deforestation, planting new forest will substantially improve our environment.
Last but not least, we have electricity production using carbon collection system. This wedge falls into electricity production sector. Large coal-burning power plants account for 25% of CO2 production. To account for one wedge, we would have to apply a carbon capturing system to 800 large, aka 1 billion watt coal power plants, or 1,600 natural gas power plants. Currently, we have 3 CCS projects worldwide that capture 1 million tons per year each. To save a wedge worth, we would need to increase our capacity to 3,500 times that.
All of our changes are rather large in scale, and thus are going to have some benefits and drawbacks with each one. Our general goal here has been to keep them economically viable, sustainable, and physically possible. No one's going to go out of business when we implement our changes. On the downside, however, the amount of startup money and capital that we would need to implement these changes is rather large, and starting them in the first place will prove very difficult. But if they can be accomplished, then sustaining them will be a breeze.
taxpayers get a 4 because while it is expensive, they will help their environment. Energy companies get a 1 because the CCS systems alone will put a serious hit on their profit margins and will make the whole process of energy production much more expensive. Manufacturers will be able to survive, it'll just change how they produce some of their goods. Industrialized governments will not like this, so they only get a 2. This is because it will take a major hit to the oil company, which for many industrialized countries is a major part of their trade. And developing governments also get a 2 because they will hate this because although they are clean, the cleanest option is never the cheapest option, and they want to use the cheapest and fastest option to get industrialized.